All right, good morning, everyone. So today we're going to be talking about vernier micrometers. The reason being is because as mechanics, we work with parts that fit together with tight tolerances. So they need to be measured with a great degree of accuracy. That being said, a vernier micrometer will read up to 1/10,000th of an inch. So imagine if you take 1 inch and you break it into 10,000 pieces, it's quite small. So this tool can do it for us. So let's have a look at a quick video here.
Hello all, just a quick video on how to read a vernier micrometer. A vernier micrometer can measure parts with an accuracy of 10,000ths of an inch. So we begin by learning the parts of the micrometer. I'm holding on to what's known as the frame. Up here we have the anvil. Over here we have the spindle. The spindle moves in and out like so with what's called the thimble. And then here we have the sleeve. On the sleeve is the main scale, and it's broken down from 0 to 1 inch by 1/100,000ths of an inch. And then each one of those 100,000ths of an inch is broken down into 25,000ths of an inch. On the thimble, we have another scale, and it's 0 to 25,000ths of an inch broken down by 1/1000th of an inch. And then finally, on the sleeve as well, we have the vernier scale. It's hard to see here, but in the PowerPoint we can see more. So now, to use one of these, we need something to measure. Well, I happen to have a socket wrench here. So to measure the socket wrench, you open up the thimble, and you're measuring between the spindle and the anvil. So you bring it down till it just touches, and then you use the ratchet stop, so you know that you have the right tension. Then you remove it, flip it over, lock it. Now it's time to read it. So to read it, we go to our scale and we see what numbers we got. So we have 900, 25, 13, and 3. So we have 938 and 3. So 0.9833 inches. So now we'll go to the PowerPoint and we'll take a more in-depth look at how to read a micrometer.
So, any questions on that so far? No. So we're going to, before we get to the PowerPoint, I'm just going to show you on the whiteboard here a little more close-up of graduation on the main scale. So the scale, as I said, is broken into 100,000ths of an inch from 0 to 1 inch. So we have 0 down here, but we'll only do 100,000 at a time. And then we have 100 over here. Okay. Not much for 1, but so be it. So then we have a line here, line here, line there. So now here is broken down again. Here, 1 line, 2 lines, 3 lines. And then this would continue on there, all that 200. So from there we got break it down again and again and again. So the way it works is it goes 0, then 100,000ths of an inch, 200,000ths of an inch, 300,000ths of an inch, so on down the line. So the 100,000 is broken into 25. So that's 25, 50, 75, 100. 125, 150, 175, 200, and so on down the line. So now we'll have a look at the PowerPoint presentation, and we'll break it down even further, see how this reads the micrometer. So now we want this one. So here we have the vernier micrometer. Okay. So getting back to the parts again, we have the frame, the anvil, the spindle, the sleeve, the thimble, the ratchet stock, and the lock. So the part to be measured, we put in between the anvil and the spindle, right? Move the spindle in and out, we turn the thimble. So now we've measured a part, and we have a graphic here that will show you what's going on. So let's go over all the parts. So down here is our main scale, correct? Right, 100 thou, 200 thou, 300 thou. Right, here we have our thimble scale, which is 0 to 25,000. So 1, 001, 002, 003, so on. And then up here we have our vernier scale, which is the 4th digit, 000. So the way this works is you try and find your biggest number. Now it looks like it's 3, but technically it's not, because we see a full 200, and then we see 25, 50, 75, but it hasn't made it all the way around to the 3 yet. So you write that down as we see 200, so that's the 00 or 200. Then we have 25, 50, 75, so it's 0.075. And then we look at this scale here, and it's showing us it's at 11. It's not exactly at 11. It's somewhere between 11 and 12. So you write down the 0.011, and then this is where the vernier scale comes in. So the vernier scale, now these lines just become lines, and the scale is over here. And the way you work the scale, if you start at 0, and you work your way all the way up to 9, and whichever line is the first line that lines up exactly with any line on the thimble is the line you want. So in this case, 0 doesn't line up with anything, 1 doesn't line up with anything, but 2 lines up here with 16, but 16 isn't used, so don't get confused with that. So that's our 4th digit there, to be 0.0002. When we add all those together, the part that we measured is 2,862 10,000ths of an inch. Or you could just say 0.2862 10,000. Now, I have another example here. We can break down. So we're going to read this one, right? So what do we see? We see 275, right? You write down 275 on the sleeve. From the sleeve, we move over to the thimble. On the thimble, we see 0, 5, 6, 7, 8, 9, so it's somewhere between 9 and 10, right? So then we need to go to the vernier scale. So we have the 275 plus the 9,000. We go to the vernier scale. We've decided that we need to see which line here lines up exactly. So the 0 line doesn't line up. 1 doesn't line up. 2 doesn't line up. 3 doesn't line up. 4 is close, but 5 is better. Right? So 0.005. So then we total those all up, and we get a grand total of 2,845 10,000ths of an inch, or just 0.2845 inches. And that's the end of our slideshow. So, any questions on the vernier micrometer? All right, well, thank you for your time. And after this, we can practice with one for real when we're allowed to get back together. So that'll be the end of the meeting. Thank you for your attendance.
Thank you. Thanks.